Images are represented as grids or matrices of what are called picture elements, which is abbreviated as pixel. In MATLAB, an image is represented as an m by n matrix in which each element corresponds to a pixel, and each element in a particular pixel stores the color for that pixel. Now, there are two basic ways in which this can be represented. There's what is called the true color, or the RGB method, and there's also an index into a color map. So again, two basic ways that we can represent color for a given pixel. The true color, or the RGB method, where RGB stands for red, green, blue. The three color components are stored in that order, red, green, and blue. The matrix is actually a three-dimensional matrix. So the m by n, that's the dimensions of our image matrix. The three layers of the matrix are the red, the green, and the blue components. The other way in which we can represent color for a given pixel is as an index into a color map. So the value that's stored in each element of the m by n matrix is an integer, which refers to a row in another matrix, which is called a color map. So with this method, we have two matrices. We have the image matrix, which is m by n, and we have a color map matrix. The color map matrix stores the red, green, and blue components in three separate columns. So the size of the color map matrix is P by 3, where P is the number of colors. But you always have three columns representing the red, the green, and the blue components. So let's take a look at an image. Here's an image of a snowy porch up in Maine. The x-axis is actually cut off, but the image matrix consists of a lot of individual elements, which are the pixel elements. So each element stores a particular color. When you have a lot of elements, you don't see the individual elements. So let's take a look at this original image again. So here's the image. Again, it's got a lot of pixels. So what we're going to do is we're going to zoom in. So over on the right-hand side where there's some trees and you see a frozen lake in the background, so somewhere around here, we're going to zoom in on that part of the matrix. So when we look at that, you can see that it's a lot grainier. So now what we're going to do is we're going to zoom in again. Way up in the upper left-hand corner, we're going to take a look at a little 50 by 50 element part of this matrix. Okay, so where we see tree here and we see background, we're going to zoom in on that. Now you can see individual pixels. So now you can see the little square blocks of color. Once we get only 50 by 50, you can actually see the individual pixels. So again, when you have a large image matrix, the pixels are really just little dots, so it looks pretty smooth. When you zoom in, you can actually see the square color elements, which are the pixels.